Hi, this is Sifei Wang, and this is my final project presentation. My project is about the diabetes prediction. Here are the 5 parts of my presentation. First part is data explanation and then data visualization. Third part is feature selection and then model selection. And the final part is the conclusion. So as diabetes is becoming a more and more prevalent metabolic disease in our daily life, both young people and elderly people are getting this disease. So it's important to diagnose this disease at an early stage for the medication and to avoid the complications of this disease, such as heart attack or kidney disease and so on. So the goal of this project is to build machine learning models to predict whether a patient is suffering from diabetes or not from the diagnostic measurements of the database. So the dataset I chose for this project is a dataset called Pima Indians Diabetes Dataset, which is from the National Institute of Diabetes and Digestive and Kidney Diseases. There are 1,768 records of the dataset, and all the patients are females and over 21 years old from the Pima Indian heritage. And there are 8 predictor variables, which are the diagnostic measurements, which will be talked about in the next page. And there is 1 target variable. 0 means that the patient is not having diabetes, and 1 means that the patient is having diabetes. So this problem is a binary classification problem. So about the predictor variables, the pregnancies means the number of times that the patient has get pregnant. All the patients are females, yeah. And the glucose means the plasma glucose concentration in an oral glucose tolerance test. The blood pressure is the diastolic blood pressure, and the skin thickness is the triceps skin fold thickness. And the insulin means the 2-hour serum insulin. The BMI means the body mass index, which is calculated by the weight and the height of the patient. And the age is in years. And the diabetes pedigree function is the possibility that the patient will get diabetes based on their his family medication records, that has their parents or ancestors have the history of having diabetes. And there is a function to calculate it. And all the variables are continuous variables. So here is the data visualization part. From the left figure, we can see that the dataset is a little bit skewed because most of the records are in the class 0, which means the patient don't have diabetes. And only 268 patients out of the 768 are having diabetes. And the right figure is the distribution of the predictor variables. We can see that most of them are following distribution similar to normal distribution, but some of them, such as the skin thickness and the insulin or so, the distribution is a little bit skewed rather than like a normal distribution. And here is the box plot and the correlation matrix of the features. We can see from the correlation matrix that none of the features are very correlated. The highest value is the correlation between age and pregnancies, but the value is 0.54. It's still very low. So we can see that our features are not correlated and independent from each other. And from the left figure, we can see that the insulin variable, there are many outliers. So this may need some further investigation. And for the feature selection part, because this is a binary classification model, so many classification machine learning methods were used in this method. So for example, logistic regression is used. So I chose to use forward selection to choose what are the important features for this logistic regression. So the result is that the glucose, BMI, and age are the important features, and the others can be eliminated. And also, here are two examples of the other classification models, the decision tree and the SVM. Here I'm using an attribute from the secular models called feature importance, which is used to selecting the minimum required features to produce a valid model. So we can see from the figure that the glucose, age, BMI are still the most important features of this prediction, and other features like diabetes, pedigree function, blood pressure are still relevant. But the skin thickness and the pregnancy seems irrelevant to the model, and so they can be eliminated. And so since this is a binary classification problem, several classification models were built to do the prediction job. So they are logistic regression, decision tree, random forest, naive Bayes, KNN, SVM, and neural network. Most of those models have their own hyperparameters. So the dataset is split into 60% of training, 20% of tuning, and 20% of testing to help build the model. So after building the model, the tuning set is used to choose the best hyperparameter for the models. For example, the k nearest neighbors is chosen k equals to 7 is the best performing one out of other k values. And after that, with each of them of the best performing hyperparameter, their performance are compared based on the dataset, based on the test set. So from the F1 score, which is the balance between precision and recall, we can see that decision tree and the linear SVM are having the best performance. Their accuracy is 74% and around 77%, which is around the average level of this Kaggle notebooks submitted online for this PIMA dataset. And here is the conclusion of my project. So first, it is possible to build classification models to predict the onset of diabetes based on the diagnostic measurements of patients. And the most important features are glucose, age, BMI, and possibly diabetes pedigree functions. And the correlation, and from the heat map, we can see that the predictor variables are not correlated. And the best models out of the 7 models and the best models out of the 7 I use, we can see that the decision tree and support vector machines are performing best. And here is my presentation. Thank you for listening, and thank you for this semester.